The problem we have here is number 49 in chapter 3. And what this problem is, or states, is that we have a plane traveling north at 192 kilometers an hour. And then after the 3 hour trip, it ends up veering off 45 degrees to the northwest at 240 kilometers an hour. So our final change in time is going to be 3 hours. And this is at a 45-degree angle. Okay, what the problem wants to know is it wants to know the initial and final velocity vectors along with what the change in velocity is, and finally what's the average acceleration over the course of the trip. So first off, we have to find our initial velocity vector. This is going to be the 92 kilometers an hour that we started out with. It's in the north direction, and therefore, as it travels straight up, it has no x component. So we can go ahead and write 0x hat kilometers an hour. But it does have a y component, which is going to be a flat 192. Y hat. Oh, on the edge there. Then we have to get the final velocity vector. This one's a little trickier as it's at a 45-degree angle. So we're going to go ahead and make a triangle. Okay. The 240 kilometers an hour is going to be the hypotenuse, as that is the side that the 240 kilometers an hour travels across. And the angle, of course, is going to be 45 degrees. So we can get the y and x component of this vector by doing some trigonometry. So sine of 45 is equivalent to the opposite over the hypotenuse. So that's y over 240 kilometers an hour. And we can just multiply this over to the other side and multiply 240 kilometers an hour on both sides in order to get our y. We can do the same thing for the x. The x is just going to be the same as the y except with cosine 45 because it's adjacent over hypotenuse, and we just pretty much do the same thing as we did with the y. Okay. So here we go. We have our x and y components of the final velocity, and we can go and put those in. Okay. It then wants us to find what the change in the velocities is. So we have to go ahead and subtract the initial from the final velocity to get our change in velocity. We can go ahead and calculate the components for the final velocity vector in order to make this easier on us. So we can take 240 cosine 45 minus 195. And for the x component, it's going to be fairly simple, as all we have to do is subtract 100 or 240 cosine 45 from 0. And if you do the calculations for these, it comes out to roughly 169.71. So 169.71 minus 0, of course, is 169.71. And then we have 169.71 minus 195. So after subtracting and adding these all up, we get 169.71 x hat plus, plus a negative 22.29 y hat. Of course, this is all kilometers an hour. Okay. Then Then we have to find the acceleration during the trip. And the formula for average acceleration is average acceleration equals the final velocity minus the initial velocity over the change in time, or the change in velocity over the change in time. And as we just found the change in velocities, all we have to do is find the change in time. But that was given to us originally as it took 3 hours for the trip. Started at time 0, ended 3 hours later. So we just have to divide our change in velocity by our time. Okay, so we can go ahead and divide the 3 into each of these numbers, and that will give us, one moment, okay, 56.57 and negative 7.43. And that's our average acceleration. We can also find the magnitude of acceleration by squaring both of these and adding them together and taking the square root, just Pythagorean theorem. Because these make a triangle, as this is the x component of the triangle and this is the y. And if we take the squares, add them together, and square root them, we get the magnitude of the average acceleration is equal to 57.01 roughly. And both of these are in kilometers an hour squared, because this is in kilometers an hour divided by hours. So kilometers an hour divided by hours multiplied by 1 over 3 hours, it ends up with the kilometers an hour squared, which is the correct unit of measure we want to be in for acceleration. And there we have it.